Hello, my name is Björn Hermann, and in this video I will show you the basics on how to build scientific figures using Inkscape software. The goal is to build the figure you can see here on the screen, and that will be sufficient to provide you with all the basics to start building scientific figures. Let's start Inkscape. So I have it already open down here. Let me just bring it up. So let's get oriented a bit first. So on the left here we have our main toolbar with a zooming tool and our selection tool and a lot of other tools. Here on the right we have some additional options that relate to each of these tools, and we will use some of those later. And here on the top we have like a normal menu like in all other software. The first thing we would want to do is to decide how wide our figure will be so that we can build it to the exact size right from the start, so that we don't need to rescale the figure later. In order to do that, let's zoom in a little bit. We may essentially decide between a 2-column figure or a 1-column figure. And Neuroscience suggests for the 2-column figure to use a width of 17.6 centimeters, and for a 1-column figure about 8.5 centimeters. In order for us to know how wide a figure is when we actually build it, we make use of these rulers here on the top and on the left. When you click here on the left and with the left mouse click and keep the mouse button pressed, then you can drag a helping line to the left and right, and we can position it at around 17.5 centimeters and also at around half of it. We may click this lock here, and that will just fix the helping lines. This essentially provides a frame in which we can operate here, either on the 1-column figure or for the 2-column figure. But let's just save the file here before it may get lost. Yeah, I just put it right here on the desktop. I'll call it Inkscape 2 tutorial. Working in Inkscape assumes that you have done some form of data plotting already in your analysis tool, for example in MATLAB or in Python. So having plotted some time courses or some bar plots or some box plots. These plots would need to be saved as some vector graphics file, for example an EPS file or an SVG file, so that we can load it here in Inkscape, which is a vector graphics program. For the purpose of this tutorial, I simulated some data in MATLAB and plotted some time courses and box plots and saved them in SVG files. I have them stored here, box plots, time course, and I also have an fMRI image that we will use. I typically load all the files that I need right from the beginning, and in order to do that, I just mark them in this folder and drag them into Inkscape. For this tutorial, I decided to build the figure as a 1-column figure. What I typically do is I rescale and rearrange these individual plots just loosely so that I get an idea about the layout of the figure. We can rescale the figures by clicking on them and using the arrows, and by pressing the Control key on the keyboard at the same time, we can keep the ratio between the width and the length. So let's just make it a little bit smaller. For the line plots, I do not worry so much about the ratio between the width and the height of the figure, because the axis here and the numbers on the axis, I will rewrite them later anyways. So let's just move them a little bit around. Let's make this a bit smaller too. And then we can zoom in a little bit further so that we get a better view. I will arrange these plots a little bit in more detail now. Requires me to send this plot here to the back. Same as this one. This is just to get an approximate idea of what the figure later may look like. That looks already pretty good. Getting closer to what we are aiming for. And so now we need to work on the actual details. So I first move the fMRI image out of the way, and also maybe box plot a little bit out of the way to focus first on the time courses. The individual parts in a plot that comes from MATLAB I often group together. So that's why I click the right mouse click and ungroup them. And often they are quite substantially grouped, so I need to do that a few times. You can see that individual parts become ungrouped. And that is MATLAB specific. It may be different for other types of software. I will first make the lines a little bit thicker here. This one by selecting a different stroke. So we can increase it here a little bit. Usually it would be good if it's in picks and points, so then 1 point, oops, maybe 1.5, blue one too. That looks pretty nice. In my MATLAB plots, there are a few hidden layers in here. I can just delete them. One needs to be careful with deleting them. If they are still grouped with some other parts, then one would delete those parts as well. So I just need to make sure that I delete nothing that is relevant. A very common step is to redo the X and Y axis, because by rescaling the figures, also the numbers and letters got rescaled. So we want to rewrite them. In this particular type of figure, I would also like to remove this axis here and rather use the axis that is on 0. In order to do that, I select the ticks and move them up using the arrow keys. Then I press the Shift button and keep it pressed and click on the axis. And so now the ticks and the axis are selected. And then I can use one of those alignment tools, this one here. And now the ticks are aligned with the x-axis that is centered on 0. I will also rewrite the numbers because they may be squished or widened based on a rescaling of the figure. Choose Arial. And I also choose a font size of 8. I would not go smaller because later in your paper the numbers would not be readable if they would be smaller than 8 points. Okay, but I don't need to worry about aligning them all manually. Just need to align the 5 and the 25. Use the Alt key, the Shift key to select all the different numbers. And then I can again use the alignment tools, this one, for example, to align on the top. And then also this one to get equal distance. Doesn't seem to be working fully well. Here we go. I will also make some cosmetic adjustments. And for that, I first need to ungroup this axis and the y-axis as well. That will allow me to change the axis because I feel we don't need the -4. We can also delete this. I will also change the stroke width. You can just select this and also this. I usually use 0.5 or 0.75. That looks pretty good. I will quickly finish the axis. Move it out of the way. And again, as before, I don't need to worry too much about arranging them manually. I will do that using the alignment tools. But that means that the 2 and the 12 need to be aligned. Use this one and this one. We also need labels. Labels may have a little bit larger font size, but that's just a matter of taste. We'll copy this. When you click on it twice on this object, then you can see that the arrows here change, so we can use that to turn this, rotate it, place it here. Then we can delete the rest. There's another small thing related to the x-axis, that it doesn't reach right to 25. That's related to the way I plotted it in MATLAB. Just extend it. So now let's move the legend out of the way. We worry about that later. And move the MRI image in here. Maybe it could be yet a little bit smaller. Just a little bit. So the remaining space we have here within our one column space, we will use for the box plots. And it doesn't seem like we have much space, but usually for box plots and bar graphs, one needs less space than one thinks. So I will squish it a little bit more. That's okay. Similar to the time course in my MATLAB plot, a lot of elements are grouped, so we need to ungroup them in order to be able to manipulate them. In order to work on the box plot, I do need to zoom in because that is a little bit more finicky here. So I need to see better. I will get rid of this frame. I just don't like it aesthetically. Be careful again, there's in the MATLAB plots, there are often these hidden layers. And one needs to be careful that they're not grouped with other elements. Okay, delete this. And that gives us already a little bit of room to breathe here. I will also make the box plot a little bit smaller, because eventually I would like that this part of the figure and this part of the figure aligns, and similarly that the bottom part of the figures also align here on the left and on the right. So I'm just anticipating how much space I will need later for the labels here and later here for these labels. I think I will zoom in yet a little bit further. It's a little bit hard to see. What I do now is I change slightly the axis here, just so that it aligns with the 1 and on the top, so that it aligns with the 4. Just looks a bit nicer. There are a few more elements grouped. We want to ungroup them, because that allows us to change now what the box plots will look like. You can use the Shift key again to mark or to select different elements of the box plot. Here then I use mostly 0.5 or 0.75. We also want to change what it looks like. Maybe, why not? We may do the same for the other box plots. So our box plots look now pretty reasonable. And we also have a little bit of space, so we can select this figure part, move it over. So just that we stay in within our one column figure. We can also move this a little bit to the left, so we have a little bit of space. We'll zoom out a little bit just to have a little bit of a look. And by using the zoom tool and clicking on the right mouse button, then it zooms out, and on the left one it zooms in. What I will do now is rewrite the axis over here, that I move it out of the way. Position labels. What we also want to do is increase the width to 0.5. And maybe even makes the ticks a little bit wider. Maybe that's too wide. That looks pretty okay. Again, using our alignment tool. This is one of the most important tools. And it looks pretty tight indeed, but maybe we do not need the label and delete it later. Let's just see. may have not given it enough space here. I think I will stop here now, just because the steps would be very similar for this box plot, and so there's not much to gain for you to watch me do that. But I do want to say a few things about the figure. Let me zoom out a little bit. Yeah, looking at the figure, I think this part could be a little bit less wide, because I have not given it enough space. I overdid it here a little bit with how tight everything is here. I could fix this by selecting these parts. Just need to make sure that I do not have the brain and the numbers and labels selected. And then I could just move it a little bit and see I get much more space here. You don't need much more. Need to quickly realign the numbers. Our alignment tool. So it's fixed already, and now we have more space if we would want to finish this part of the figure, which I won't do right now. Overall, our figure looks fairly similar to what we were going for. Shown here. It does look a little bit nicer on the left, and it's because, again, I made it too tight over here. But overall, it looks fairly similar. What is left to do now is to save the file in a way so that we can submit it as a figure file to a journal. One way to do that is to use the SVG file we saved already and submit that directly to the journal. They often accept SVG files, so vector graphics files. Another option is to print it as a PDF. That requires you to have some virtual printer, so the PDF printer installed on your computer. But the advantage of printing a PDF is that all the information is stored in the file, and it can also support vector graphics, and even the fonts are stored in the file, which may not be the case for the SVG file. So that's what it looks like in the PDF. You may also load the PDF file then in GIMP, which is a pixel graphics program. GIMP stands for GNU Image Manipulation Program, so GIMP. And yeah, as I said, it's a pixel graphics program, and so that allows us to get a pixel image of our figure. So let me load the PDF file. So now when we open the PDF file in GIMP, then we have to select or choose the resolution the final pixel figure or pixel image will have. And so this is in dots per inch or pixels per inch. And for figures submitted to journals, a resolution of 600 or 800 or even 1000 pixels per inch is pretty reasonable. Let's just choose 600 for now. We press import, and then it imports the our figure. We may also choose the selection tool, select the part where there's actually something in our figure, use image and crop, and then zoom in. So here we can see our figure. Finally, we export it as a PNG file, which is a pixel graphics file, which allows for transparency, and it also doesn't have any quality loss, so it compresses the information, but it does not lose any information. Let me just open it. That is what it looks like. It looks fairly similar to what we were going for originally. So now we have saved our figure as a PNG file, so it's a pixel graphic file, and as a PDF file, which is also stores all the vector information, and also as an SVG file. So we have multiple files available that you can use to submit to a journal or send to your co-authors or place into your manuscript file. So this concludes this tutorial on how to build scientific figures using Inkscape and exporting it into GIMP or saving it as a PDF file. I would encourage you to check out a lot of other figures from other papers, because this tutorial just provides you with some technical basics that allow you to start building nice figures, but developing an eye for what works takes a little bit of time.